Hi everyone, this is very interesting video. In this video you will learn how you can control COMSOL Multiphysics simulation using Python. That's right. This is very interesting because I've been waiting for this feature quite a long time and I never thought there is a simple Python package available that will actually help you to control your model using Python. That is very handy and I will just show you few of the very basic advantages of controlling COMSOL using Python. So let us first understand how the workflow actually works. So as we know, for beginners and everyone traditionally using the software, we generally use the software to actually run the simulation, get the plot and do our own research. We most of the time do not use MATLAB or Java. But for slightly advanced user or those who need customization, they usually use COMSOL with Java. So this adds up a new dimension of programming where you can repeat a particular task or do something in bulk. For example, you can create thousands of nanoparticle and other geometries just by writing few lines of codes, and if you want to do that without the programming in the geometry section in the software, it is quite tough. So this is one example. Now let's learn how the system works. So we have Python, as we all know, and in Python there are packages such as jpipe and mph that helps to connect Python with Java and in return using Java's API to run and connect with the COMSOL model. So we are in COMSOL and at first we will create a sample file and then we will see how we will use Python to access the data, run the model and get the results. So this is just the interface and we will just create a simple resistive model where we will have some materials and we'll calculate the current through that material. So I'll go on to the add component and click on 2D. It might take few seconds and then at first I will define a parameter. The parameter name is voltage and I will write as 1. So this will act like 1 voltage. Okay. So in the geometry, we'll create a rectangle. To do that, I will go on to geometry, click on rectangle. In the width, I will write 1 and height, I will write 0.8 and I'll click on build our object. I'll go on to sketch and then create a circle. So I'll just draw a random circle here and I will add a point. So let's add a point here. Okay. Then I will go back to the geometry and click on build our object. So this is our geometry. Now the next part is that we will add materials in the model. To do that, I'll just go on to materials and then add 2 blank material. So this is 1 and this is 2. Now I'll go on to physics. So we'll click on the electric current and then add to the component. In this way, we can easily add a particular physics in that model, provided we have that physics installed in the software. Now we will add a floating potential, or we can just add a terminal and we'll select one side of it and we'll again right click and click on ground and we'll select the other side. In the terminal, we'll just open up the parameter and copy the voltage, come back to the terminal and choose voltage and just paste it. So we have the voltage terminal and the ground. Now we'll go on to the material and choose the outer material to be the material 1 and the inner one to be material 2. In material 1, let's take the electrical conductivity to be 100, and material 2, let us take the material conductivity to be a slightly lower value, let's say 2. Now our model is almost done, so I'll just click on finer, and then we'll go on to study, we'll go on to stationary and click on add study, and we'll click on compute. It might take few seconds, and then as soon as it is solved, we'll get the default model, and you can see that we have the electric field norm and the potential plot. So now I will show you how you need to set up Python so that you can bridge Python and use it to control your model. I assume that you already have COMSOL Multiphysics set up in your system with all the necessary license and tools. So I'll just focus on the Python part. So either you can download Python from the official website, that is python.org. You can just download Python, or you can use the VS Code, that is the Microsoft Visual Studio Code, and this can also be used to run the Python codes. Okay, so after you have installed the software, you might need few different packages and tools that are required to run the software. So after that, you need to install the mph package. So as you can see that you can just install it using the command prompt, and you just need to type pip install mph and it will be installed in your system. So as you can see, it gives you some details about the tool. So you can see mph brings the deadly missing power of Python to the world of COMSOL. It leverages the Java bridge provided by JPipe to access the COMSOL API and wraps it in a layer of Pythonic ease of use. The Python wrapper covers a common scripting tasks such as loading a model from a file, modifying parameters, importing data, and then run the simulation, evaluate the result, and export them. So COMSOL models are marked by the mph file extension. Okay, so this tool we will be using to control our model. Now let us directly jump into our tutorial so that we can start learning. By the way, I will try to create a blog article explaining how you can install this particular package in your system, so you can check in the description. So now that we have installed all the packages, now let us start writing the code. The first thing, we need to import the packages. So you will write import mph, enter, and then we will import numpy. So we will write import numpy as np. So these two lines are actually importing the mph package and the numpy package. Numpy is used to actually do the calculation of numbers in a simple term. Now the important line here is that we need to call the client. So we will write client equal to mph dot start, and we'll open close the bracket. So this will actually start the mph client. In the next line, we'll create the model. So we'll write model equal to client dot load, and here we will write the file name. So the file name, we wrote v solved underscore 2volt dot mph. Okay, now let us run this code and then we will see what happens. Okay, so I'll click here and I'll just click on interactive code. So it might take few seconds to run the code for the first time, and then it will just quickly run all the different codes that we are working. Okay, so to check if everything is working fine, we can just type print client dot names and see if it works. So I'll just click here and you can see that I got an output. So these are the different clients that we are working. So vsalt, probably I ran it 2 times, so it is coming 2 times here. So this is the client that we loaded, that's why it is showing here. Now let us see the model parameter. So we'll write print model dot parameters, open and close brackets, and then we'll run this code. So you can see that the voltage is 2. Why the voltage is 2? Because in my model I have a parameter where I have set up the voltage to be 2. So if you see the model that I have opened in a separate window, you can see I have a voltage that is 2, as you can see it here, okay? And I have the electric current physics and I have the 2 different materials. Now let's say I want to check the material in the model. In that case we will write print model dot materials, open and close brackets, and we'll press shift enter. So as I showed you in the model, I have 2 different materials, so it is showing material 1 and material 2. Note that you do not need to open COMSOL Multiphysics to run all these codes. This will independently run in Python. In the front end, in the back end, it will connect with Java, API, and so on, that we need not worry about. Similarly, if you want to check what is the physics that is present in the model, so you can just type print model dot physics and press shift enter, and you can see that the electric current physics is used in the model. So it is quite easy and you can easily check the different parameters in the model. Now that you have learned how to get the different values from the MPH model in Python, now let us move a step further. Now let us see how you can set a value from Python directly into the MPH file and change the parameters. So to do that, we will use the command model.parameter to set the values. So I will write model.parameter and I will open the bracket. In the quotation, I will write the parameter name, that is voltage. Then I'll put a comma and then I will write the value. Let's say I want to save it as 20 volts. Now I'll just press enter. I'll just press shift enter. So that is set. Now we need to build the model. So I'll write model dot build, open and close bracket, and the model is built. Now let us save the model. So I will write model dot save and let us name the file. So we will write vsalt underscore 20 volts and we'll press shift enter. So you can see that it took 1.8 seconds to save the file. Now let us check our folder if the file is actually saved. So I'll open up the window. So you can see that I have a file named vsalt underscore 20 volt and it is 1.47 MB. So we have the same file but with a parameter of 20 volt. So let us open the file and see if it actually changed. As you can see, since I've opened the file, you see that the voltage is set to 20. So you can see using Python we can directly update the value of a parameter in the model. Not only you can update the value of parameter, you can pretty much change any of the value anywhere, and you can even run the simulation using Python. So we'll learn that in the later section of the video, or maybe in subsequent lessons. So do subscribe to this channel for more advanced tutorial like this. So let's go back to the code and learn few of the more important commands. So now let us learn some advanced codes. What we will do, we'll try to use Python to actually create 10 different models of different voltages, and for each voltages the model will run and save the voltage profile as a PNG file, and all this will happen with a single click. So not even 10, you can create thousands of model with thousands of graph using this technique. And not only graph, you can do it pretty much with any data and any analysis. That is the power of Python. So let's see how we can do that. At first, we need to import the models, open up the client and load the model, and then what we will do, we will try to first create a loop and then run everything inside the loop. So this is the script that we are creating, that is part1.py. So let us create the loop first. So we'll write for voltage in range. Let us take an initial value. So to do that, I will just create a variable called VINT equal to 2 volt and V max equal to 10 volt. Okay, so let us define the range as VINT comma VMAX. Okay, so we are done with the loop. Now we will write all the code inside the loop so that it can run from VINT to Vmax. So at first we will write model dot parameters, and we will here write voltage comma str voltage. Okay, sorry. So let me explain what is going on. So you are running a for loop that will start from 2 and end at 10, and we are setting the parameter voltage to the different voltages that the loop will run. Okay, and now we will print the parameters. So print, let's say we write current parameters comma model dot parameters. Okay, now the third line will build the model. So model dot build, and then this is the most important part, that is we will solve in the model. So model dot solve, and then we need to mention the study. So one single model can have multiple study, so we need to specify the study. Since in our study we only have one, and that is the first one, so we'll write study 1. And here we will write vdata equal to model dot evaluate, open and close brackets, and in third bracket we'll write 0 comma 0 comma V, that is the voltage, and then we'll calculate the V max. So this is NP dot max NP dot concatenate and then V data. Okay, I will press enter. So let me explain what is going on. So we solve the model here and then we calculate the data in the model for the voltage, and then we calculate the maximum voltage of all the data in the solution. Now the fun part, we'll print the maximum value. So print maximum voltage comma V max. Okay, now we'll write model dot export. So this line will export the output image as a PNG file. So we'll write image 1 comma F V solved underscore voltage V dot PNG, and then we'll write model dot save. And we'll just copy this because I'm too lazy to just write everything once again. So I'll just copy this, and in the save I'll just paste this. So let's see, I'll just run the code and see what is happening. So I'll click on run, and I also have my window open so that you can see what is happening. So I'll click on run. So I'll just have my window open. If it works, then probably the file should be updated here. So you can see that the maximum voltage is 5 volt, and so probably I went through some error. I'll just check. Probably something went wrong. So I'm back, and there was some error because I have set up the voltage to be constant. So now I fixed the code. So you can see at first we are importing the model, then loading the client, setting up the maximum minimum voltage, and we have the loop where we are calculating the maximum value, and we are saving each of the graph and the model. So let us start from 2 and end with 12. So from 2 volt to 12 volt. Now let's run the file. Okay, so we'll click on run Python file and it will start working. So in the meantime, I'll also open the folder so that you can see in real time what is happening. So you can wait few seconds, and then you will see that after every 5 to 10 seconds you will have a model. So you can see that the current parameters is voltage 2 because it is starting from V int equal to 2, and the maximum voltage is also calculated. Since this is a basic model, so we know that the initial voltage is the maximum voltage because the other side is grounded. So it is plotting the calculating the maximum voltage. So you can see 2, 3, 4, 5, and similarly in real time the files are being created. So you can see if I click on a medium icon, you can see the PNG plots and the model files are being created in real time as the code runs. So you can see that if you are working on a complicated model and you need to automate some task, as well as you need to see the plots in the model, or let's say some data in the model, you can do that by automating using Python. So you can see that if I click on details, so each of the file names are saved with the initial voltage so that you can easily identify, and also each of the file we have the nice plot for each of the voltages. So this is how you create a script in Python. Note that you can do this in Java as well, but Python is versatile and you can connect Python with anything else. So for example, if you are working on a DFT model, okay, so what you can do, you can have a piece of code where you are doing the DFT calculations, and let's say you are calculating some optical parameter. Then you can put in the DFT calculation optical parameters in the COMSOL model, run the model, get the value, and then you can connect it to some other model or some other experiment and so on. So the possibility are endless. Or let's say you are working on ANSYS in a particular model. You need some data that you want to feed in to COMSOL Multiphysics. That you can do too. Or let's say you are working on deep learning based model where you have a lot of data and you want the predicted data to be the input in a COMSOL Multiphysics file. In that case, you can just substitute the value and run the model. So the possibilities are actually endless. So I thought to make a tutorial so that you get to know about the possibility of using Python in COMSOL Multiphysics. I hope this helps. Please do subscribe to this channel to see more interesting and quality videos in science and engineering. Thanks for watching. Have a nice day ahead.